Okay, so we're going to be looking at two things today. First of all, we're going to be looking at the molecular clock, which is a way using DNA that we can work out when two species diverged. Diverged meaning they split into two separate groups. So, as I said there, that's what it's for. It's a tool used to estimate when one species diverged from another. And what it does is it relies on the idea that mutations build up at a relatively reliable and predictable rate over time. So, for example, we may know in a particular gene that a mutation will happen once every 10 million years, for example. Okay? So we can say predictably every X million years a mutation will happen. So it's predictable like that. So what I put here is an example for you to have a go at. So let's say, for example, we know that a mutation happens every 15 million years, okay? And we know that two groups have 4 differences between them in that sequence. Based off that information, when did those groups diverge or split from one another? So maybe pause the video, have a read through that, and I'll reveal the answer in just a second. So the answer would be 60 million years, because if there's a mutation every 15 million years, and there are 4 differences between the two sequences, which must have been caused by mutation, 4 times 15 gives 60 million years in that case. So that's just all there is to the molecular clock. There's not too much about it. You do see occasional questions about it, usually multiple choice. They'll give you a premise quite similar to what I did there. So just be aware, look out for what they say about the how frequent the mutations are. They might give you 2 sequences, you need to find how many differences there are, and based off that information, work it out. So nothing too complicated, but just make sure you're familiar with that idea. If you want me to go over that in more detail, of course, log into Zoom. I'll be happy to go through that with you. So the second thing that I wanted to go through today is just the idea of biogeography, which just provides a bit of background for what we were looking at previously with evidence for evolution and distribution of fossils. Excuse me. So as I said there, biogeography is the study of geographic distribution of species over time, and it provides evidence for the theory of plate tectonics and continental drift. So what the distribution of fossils today shows us is that land blocks that used to be joined together are now very distantly separated. So for example, South America and Africa, the west coast of Africa and the east coast of South America have fossils of the same species. Now, these are land-based species as well. It wouldn't be possible for them to swim the distance between South America and Africa, so the only rational explanation for that is that those blocks of land used to be joined together. And if you look at a map as well, you can see that South America and Africa have a shape that joins together quite neatly, and we do find the same rocks on those 2 coasts as well, showing that they probably did used to be together. If we go way back in time, Earth was like this diagram here, where there was just one big supercontinent that we called Pangaea, okay? That formed about 280 million years ago. So there were blocks of land that were separate, and then they formed together to form Pangaea. Then over many millions of years, they did begin to separate. About 200 million years ago, they separated into 2 megacontinents called Laurasia and Gondwana land. And then from there, things separated more and changed over time. If you look elsewhere on YouTube, you can find some lapses that show you how the continent changed over time, going from billions of years ago all the way through today. I'll see if I can find one of those and post it for you. It could be quite interesting to look at. And just be aware that, like I say, Pangaea formed from other continents coming together, and that caused a mass extinction. So you're probably aware, an extinction is when a species fully dies out and there are no more left, and a mass extinction is when a very large number of species all die out in a relatively short period of time. With the scale of the Earth, a relatively short period of time could still be hundreds of thousands of years, or even 1 or 2 million years. when you're talking about something that's billions of years old like Earth, that is a short amount of time. So when, before Pangaea, there were blocks of land all separated, when they all formed together, that massively reduced the amount of coastline. And lots of living things at that time lived in like the coastal regions of Earth. There wasn't much animal life on land. Most animal life would have been restricted to living in coastal areas rather than deep inland. So when Pangaea formed and the amount of coast reduced, that just forced increased competition in the amount of space. And by some estimates, we believe about 95% of species died out when Pangaea formed. Obviously, the most famous mass extinction is the one that killed off the dinosaurs. That happened about 66 million years ago when a huge asteroid or meteor, ask a physics teacher, I forget the difference between those, but when a space rock, let's say, hit into Earth and caused huge damage, what that did is, as well as causing a big shockwave, which would have killed many dinosaurs instantly, it also caused severe climate change with all the ash that went up into the atmosphere. Which for a cold-blooded group, that's what killed them off. So that's just a few things to go over, really. I'm really hoping that we'll be back into face-to-face learning soon. So I'm just ticking off a few more things before we get into the stuff we'll be looking at when, fingers crossed, we're back. So yeah, as ever, work on the tasks on Google Classroom, and if you need any help, log into Zoom and I'll be there. Okay, thanks.